Here is the statement of question number 6. If gx is equal to x square plus 5, express each of the following in terms of x. Part A, g at a. Part B, g at a plus 1. Part C, g at a plus 1 minus g at a minus 1. To find out g at a, we have just to replace x with a. So g at a is equal to a square plus 5. Now to find out g at a plus 1, we have replaced x with a plus 1. We have applied the identity, and now this is a square plus 2a plus 1 plus 5, right? Finally, it results as a square plus 2a plus 6. In part C, we have to find out g at a plus 1 minus g at a minus 1. Now we have found g at a minus 1, which results a square minus 2a plus 6. And the value of g at a plus 1 we will take from what we have done in part B. To find out g at a plus 1 minus g at a minus 1, we have put the value of g at a plus 1 from the previous part here, and then minus this one, and then the value of g at a minus 1 we have calculated here. Now solve it. On opening the bracket, after the cancellation here, the final result of g at a plus 1 minus g at a minus 1 is 4a. Now statement of question number 7. Given that fx is equal to 1 over 2 x into x plus 1, evaluate the following. Part A, f at x plus 1, f at x minus 1. Then part B, f at x plus 1. Then part C, f at x minus f at x minus 1. And part D, f at x square. It is the given function f at x equal to 1 over 2x into x plus 1. Now to find out f at x minus 1, in place of x we will put x minus 1. This way f at x minus 1 is solved. Now minus 1 and 1 is cancelled out. Finally it results x into x minus 1 by 2. In the second part, we have to find out f at x plus 1. We have substituted x plus 1 instead of x in the function. After this substitution, we have solved it, and the final result we have got x square plus 3x plus 2 by 2. In this part, we have to find out f at x minus f at x minus 1. Now putting the values, it is the value of fx, and this is the value of f at x minus 1. We have done it in the previous part, part A. Now we will solve it. Now x square is cancelled out with x minus x square, and the final result we have got x. In part D, we have to find out f at x square. This way we have solved it for f at x square. Here is the statement of question number 8. Given that the function fx is equal to x by 2 plus 3 and gx is equal to 3 by 4x minus 2. Part A, find the values of part 1, f at 2 plus g at 2. Number 2, f at minus 1 minus g at minus 1. Number 3, 2f at 4 minus 3g at 6. Part 4, 5f at minus 2 minus 7g at minus 4. Now part B, what are the values of x for which fx is equal to gx and fx is equal to 17? Here are the functions given to us. Fx equal to x by 2 plus 3. Now to find out f at 2, in the same way, gx is given and we will find out g at 2. Here we have found that f at 2 comes 4 and g at 2 comes minus 1 by 2. Now to find out f at 2 plus g at 2, adding the values, it comes 3 whole 1 by 2. Do part 2 and part 3 in the same way how you have done part 1. Now I am doing part 4. Here we have to calculate 5f at minus 2 minus 7g at minus 4. To find out 5f at minus 2 minus 7g at minus 4, I have put the values uh, in fx, instead of x putting minus 2, and in gx instead of x putting minus 4, solving it accordingly. Solving it further, opening the bracket comes 5 multiplied by 2, opening the bracket results minus 7 multiplied by minus 5. Now 10 plus 35 results 45. In part B, we have to find out the value of x when fx is equal to gx. Applying the condition that fx is equal to gx, this becomes an equation. Solve it. It's a linear equation. Multiply whole the equation with LCM of the denominators, which is 4. It results 2x plus 12 equal to 3x minus 8. Now shifting the variables to the left and constants towards right with change in their signs, it results x equal to 20. In the second part of this part B, the condition is given that fx is equal to 17. It will develop a linear equation where we have to find out the value of x. Now multiplying both the sides by 2 results x equal to 28. The statement of question number 9 is given that the function fx equal to 5x minus 9 and gx equal to 2 minus 6x. Find the values of x, which part A, fx equal to 16, b, gx equal to 14, c, gx equal to x, d, fx equal to 2x, e, fx equal to gx, f, 2fx equal to 3gx. These are the conditions which will help us to develop an equation. Then we'll solve it accordingly to find out the value of x. We are doing part B here. The condition given with us is gx equal to 14. So this is an equation. We will solve it to find out the value of x. 6x equal to minus 12 and x equal to minus 2. Now we are doing part D here. The condition is given fx equal to 2x. So this is the equation. We have to work on it to find out the value of x. Solving this linear equation, x results 3. In part F, we are given that 2fx equal to 3gx. This is an equation. We will solve it. First opening the bracket. Now shifting x carrying terms towards left and constant towards right with change in their signs. X equal to 24 by 28. Now after cancellation, x equal to 6 by 7. Now question 10, statement of the question is, if hx is equal to x square minus 5x plus 4, part A, express h at 2a minus h at a in terms of a. B, find the values of a which h a equal to 0. C, express h a square plus h at a in terms of a. This is the function given with us. We have to find it out in terms of a. Now we solve it. Opening the bracket, we have got that Plus 4 is cancelable with this minus 4. Now it results 3a square minus 5a. Now part B, here we are given that h at a equal to 0. According to this condition, we have got a quadratic equation. We'll solve it through factorization. This is the midterm split. Taking a minus 4 common, either a minus 4 equal to 0 or a minus 1 equal to 0. This way it results a equal to 4 or a equal to 1. We are supposed to find out h at a square plus h at a in terms of a. Now we solve it. Opening the brackets, it results this way. Solving this algebraic sentence, it results to a to the power 4 minus 4a square minus 5a plus 8. Now the statement of question number 11, given that the function gx equal to mx plus c and that g at 1 is equal to 5 and g at 5 is equal to minus 4, find the values of m and of c. Hence, evaluate g at 3 and g at minus 4. It is question number 11. Here we are given gx is equal to mx plus c and g at 1 is equal to 5 and g at 5 is equal to minus 4. With the help of these two conditions, we have developed two equations. Now we solve these two equations simultaneously to find out the values of m and c. Subtracting first equation from second, m results minus 2 whole 1 by 4. Putting this value of m in equation number 1, we have got c equal to 7 whole 1 by 4. Now putting these two values of m and c in the function gx, we get this is the function gx. Now g at 3, putting 3 in place of x, this is how we have solved for g at 3, which results 1 by 2. This is how we are going to find out g at minus 4, putting minus 4 in place of x in the function. It's equal to 9 plus 7 whole 1 by 4, which results 16 whole 1 by 4. All the best. See you in the next lesson. Bye.